Good morning, everyone. In the last lecture, we discussed stepwise procedures to formulate linear programming problem. See, when the mathematical model is framed, then the next task is to solve linear programming problem. For that, we have different methods like graphical method or simplex method. Today we are going to focus on the graphical methods to solve linear programming problem, especially by taking the example of maximization of profit. So consider one problem. See, a company manufacture two products, namely X and Y. And these products are possessed on machines, that is machine 1 and machine 2. The manufacturing of product X require the processing of machine by 6 hours per unit. At the same time, the manufacturing of Y require the processing of 1 by 4 hours per unit. See, similarly, the manufacture of product X require the processing of 2 hours per unit of machine 2, and the manufacturing of the product Y require the 4 hours per unit of machine 2. At the same time, the total availability of machine 1 is 7,200 hours per month, and the total availability of the machine 2 is only 4,000 hours per month. Now, here the profit per unit sale of the product X is rupees 100 and the profit of the product Y is rupee 80. Now our question is that find out the monthly product of X and Y so as to maximize the profit by using the graphical method. So in order to solve the graphical method, in order to solve the linear programming problem by using the graphical method, first we have to formulate the mathematical model. So from the given question, see, we already said that a company manufactured two products, namely X and Y. So I am taking here the product X and Y here. See, these products are possessed on two machines. One is machine 1 and another one is machine 2. And the manufacturing of the product X, which require the processing of machine hours by 6 hours per unit. At the same time, the manufacturing of the product Y, which require the processing of machine by 4 hours per unit. So this information is given. Similarly, for processing of product X, the machine 2 is also required. And here the product X requires the machine 2 of the processing of 2 hours per unit. And at the same time for the product Y, it requires 4 hours per unit of machine. So I am going to incorporate here, that is the product X require machine 2 hours per unit and product Y require 4 hours per unit. Now, here the total availability of machine 1 and machine 2 is also given. See, the total availability of machine 1 is 7,200 hours per month. So I am going to incorporate here the total availability of machine 1, that is 7,200 hours per month, and similarly the total availability of machine 2 is also given, that is it is 4,000 hours per month. So this is one of the limitation, and at the same time one more information which is given in the problem, that is the profit per unit sale of the product. If you are going to sell the product X in the market, then the profit of rupee 100 and the product from product Y, the profit of 80 rupees is also getting. So that we are also going to incorporate here. See, profit per unit of sale of commodity X is rupee 100 and Y it is 80 rupees. So now we are going to represent all this information in a tabular form. See, we are represented here, and our problem is that company wants to maximize its profit. So this is our problem, and how many units of commodity X and Y should be produced by the producer or company so as to maximize the profit. See, this is the entire information which given in the problem, and at the same time, by using this particular table, we have to identify, what are our decision variable, what is our objective function. Then after that, we have to identify what are the constraints. Then after that, we are going for, non-negativity constraint of the variables. So now, first one, we have to consider from the given table, we have to consider what is our objective function. Here, of course, the decision variables are here. It is the product X and Y. So this is the decision variable, that is product X and Y. And at the same time, the company wants to maximize profit. So our objective function will be the maximization of profit. Maximization of profit will be our objective function. And here, what is our profit which is given? That is from the sale of product X, it is 100 rupees, and from the sale of product Y, it is 80 rupees. So I am writing here our objective function, that is we want to maximize Z. Z I am denoting in terms of profit, which is equal to 100 into X, that is 100X plus 80Y, because this is the profit rate which is given for the commodity X and Y respectively. So this is the objective function, that is maximization of profit, and our maximize the profit which is equal to 100X plus 80Y. Now after specifying our objective function, next one we have to identify our constraint. See, what are the constraint here? We are subjected to the constraint, that is the total availability of machine 1 and machine 2 which are given. That means the maximum availability of machine 1 per month is 7,200, and similarly machine 2 is 4,000. Now by considering these two constraints, see, we are going to frame the constraint here. It is 6x plus 4y which is less than or equal to 7,200. See, from the machine 1, we know that commodity X which is using 6 unit per hour and 4 unit per hour of machine 1, especially for producing commodity Y. So here the topic is, that is given objective function is subjected to the constraint, that is 6x plus 4y which is less than or equal to, that means maximum of 7,200. So it is less than or equal to 7,200. Similarly, our second constraint related to the machine 2, so it is 2x plus 4y less than or equal to 4,000. I can write here, it is 2x plus 4y which is less than or equal to 4,000. So we have a two constraint here. So after finalizing our constraint, then the next thing, that is we have to frame the non-negativity of the variables, that is here the two decision variable, that is x and y, which are assumed to be greater than or equal to 0. X is greater than equal to 0 and the y is also greater than or equal to 0. Now we are going to frame the mathematical formulation of linear programming here. So here our profit function, that is maximization of profit, that is z is equal to 100x plus 80y, subjected to the constraint, that is we have a two constraint, that is 6x plus 4y which is less than equal to 7,200 and 2x plus 4y which is less than or equal to 4,000. At the same time, it is subjected to the, see, it is x is greater than or equal to 0 and y is also greater than equal to 0. So now our mathematical formulation of given linear programming problem is completed. Now by using this particular mathematical formulation, now we can go for finding the solution of this given linear programming problem by using the graphical method. See, the first step was nothing but it was mathematical formulation. And after that, the second step is we have to construct a graph and plot the constraint line. So here we have a graph on a horizontal axis. I am showing here on the horizontal axis we are going to take the commodity X, and along the y-axis we are going to take the commodity y. Now we want to plot the constraints, whatever the constraints which are given in the linear programming problem, which we are going to plot here on the graph, and for that first we want to find out the coordinates of the constraint. So how can we find the coordinates of the constraint here? See, for this particular purpose, replace the inequality sign in the each constraint by equality sign. See, first we are going to consider the constraint number 1. See, the constraint number 1, which was 6x plus 4y, which is less than or equal to 7200. But now this inequality sign, we are making it to a equality sign, making it into a equality sign. So it will become, see, it is 6x plus 4y, which is equal to 7200. Now we are going to find out the value of x considering the value of y is equal to 0. So we are assuming here the value of y is equal to 0, and we are going to find out the value of x by assuming the value of y is equal to 0. So how it will be? See here, I am going to substitute, this is our equation. Now 6x plus 4 into y, instead of y, here we are assuming it is equal to 0. So it is 4 into 0, which is equal to 7200. So if you go for solving it, then 4 into 0, it will become 0. Then it is 6x is equal to 7200. By dividing the both side of this equation by using 6, it will become, see, x is equal to 7200 divided by 6, which is equal to 1200. So here our coordinate point, that means when y is equal to 0, our value of x is equal to 1200. Similarly, let us assuming that the value of x is equal to 0. Just opposite of that. Earlier we assumed that y is equal to 0. Now we are assuming that x is equal to 0, and we are going to find out the value of y. So here the value of y will be, see, 6x plus 4y is equal to 7200. We are going to substitute x is equal to 0. So it is 6 into 0 plus 4y, which is equal to 7200. So this term will become 0. Then 4y is equal to 7200. Dividing the both side of the equation by using 4, then it will become 7200 divided by 4, which is equal to 1800. So our another coordinate point, that is when x is equal to 0, then our value of y is equal to 1800. Now we are going to plot these values here to make a constraint line, that is, which is joining the points of 1200, 0 and 0, 1800. So in order to mark the point on the graph, we need to select the appropriate scale as well. So we have to take the appropriate scale here. Which scale will be entirely depending upon, the maximum value of x and y. Here the maximum value of x is equal to, see, it is 1200, and here the maximum value of y is equal to 1800. So here we are going to take, 0, 500, 1000, 1500, 2000, similarly in the both axes, that is x and y axis. Now by using this coordinate point, first we are going to consider this particular point, that is 0 and 1200. That means when y is equal to 0, then our x will be, see, it will become at this particular point 1200. It will be 1200 somewhere here. And similarly, when x is equal to 0, our value of y is equal to 1800. So somewhat here. So I am joining these 2 points, then it will become like this. We will get a straight line here. Okay, now I am denoting this particular line as the first constraint, that is 6x plus 4y, which is equal to 7200. This particular line is showing for the constraint number 1, that is 6x plus 4y, which is equal to 7200. Now we are considered only constraint number 1. We again going to consider the constraint number 2 also. So we are going to consider the second constraint, that is constraint number 2. That was 2x plus 4y, which is less than or equal to 4000. Now here again we are going to make this inequality sign into the equality. So it will become, see, 2x plus 4y, which is equal to 4000. So now we are assuming that y is equal to 0, then we are going to find out the value of x. So here our equation is 2x plus 4y is equal to 4000. Substituting here the value of y is equal to 0, then it will become, see, 2x plus 4 into 0, which is equal to 4000. So if you go for simplifying it, 2x is equal to 4000. Dividing the both side of the equation by using 2, then it will become, see, x is equal to 4000 divided by 2, which is equal to 2000. So this is the coordinate point, that is 2000 and 0. That means when y is equal to 0, our x is equal to 2000. Similarly, just to opposite of this, we are going to assume x is equal to 0 and we are going to find the value of y. So here, this is our equation. We are going to substitute x is equal to 0. So it will become 2 into 0 plus 4y, which is equal to 4000. 2 into 0, which will become 0. Then 4y is equal to 4000. We are dividing the both side of the equation by using 4. Then y is equal to 4000 divided by 4, which is equal to 1000. So when our x is equal to 0, then value of y is equal to 1000. Now we have two coordinate points here. We are again going to plot on the graph. So here I am going to consider, see, 2 points. One is when x is equal to 0, y is equal to 1000. And similarly, when y is equal to 0, then x is equal to 2000. So these 2 points are there. I am going to draw a particular line by joining these 2 points. So it will become like this, 2000 here and here it is 1000. So we have a 2 line, and this blue line which is showing for the constraint, that is 2x plus 4y is equal to 0. So we have a 2 lines here, and these 2 lines are representing for the 2 constraints. After that, after drawing these 2 lines, which represent 2 constraints, on the next step we have to identify, feasible region. And what is the feasible region? It is the region which is bounded by the constraint. So we can say that feasible region is the region which is bounded by the constraint. And all the point inside the feasible region, or all the boundary of the feasible region, or at the corner point of the feasible region, that actually satisfy the constraint. So here, both constraints are less than, both constraints are less than or equal to 0. You just recall it, our constraints were less than or equal to 0. So it is the type which is happening in the case of a maximization of objective function. So here, the feasible region in this case should be inside, below this particular curve. So upper portion, see here, it is this particular portion of the blue line, and this particular portion of the red line below portion will be considered as the feasible region. So here the solution phase, given linear programming problem, see, any point inside this particular region, I'm going to shade this particular region. See, this particular region will be considered as, see, this shaded region is considered as the feasible solution. So this is, we have a different corner points are there. So I am denoting here, this give the value of x and y at this, within this particular area, or any on the particular line, generally considered as the feasible region. So here, this feasible region says that the value of x and y that satisfy all the constraint. Hence our region will be, see here, I am denoting this shaded region will be considered as the feasible region. So I am denoting here the points. One is here, it is origin. Then here we have a point A. Here the intersection point we have, that is B. And here the intersection at the point X, at the x-axis, which is equal to C. So here the feasible region is the polygon, that is O, A, B, C. This particular region will become inside, because our constraint is showing that is less than or equal to. So this is the less than or equal to area. So we can say that this is the feasible region. So here the O, A, B and C are called, all these are the vertex or the corner points of the feasible region. See, this is the corner point, one is 0. Then here it is another one A. And this is the intersection point B. and this is the point C. We can say that these are the corner point, or it is also known as it is vertex points of the feasible region. So I am writing here all these points. See, out of this feasible region, we want to find out the optimal solution. See, once the graphical solution can also be used, find out the optimal solution for a given problem. So here we are going to find the optimal point, which is the final stage. And any point in the feasible region that gives the maximum or minimum value of the objective function, which is generally called it is optimal solution. So optimal solution here, see, which is one of the feasible region, one of the point on the feasible region is considered as the optimal solution. So in the feasible region, we can see there are many points that satisfy the constraint simultaneously. That is here 0, A, B, C. So out of this, which will be the optimal point? So for that, optimal point is always lies at the one of the vertices, or the corner of the feasible region. So it is origin point, or it may be A, or it may be B, or it may be C. So optimal solution always lies at one of the vertices or the corner of the feasible region. So of course we have a 4 vertices here, or four corner points are here, that is one is 0 or origin, A, B and C. I am going to write here. See, it will be at 0, or it is the origin point, we can say that it is O. At this O, the value of x is equal to 0 and the value of y, which is also equal to 0. Then at point A, see, at the point A, value of x is equal to 0 and value of y is equal to 1000. Value of y is equal to 1000. I have written here x is equal to 0 and y is equal to 1000. Similarly, at the point B, see, at this particular point, both curves are intersecting. Both lines are, or both constraints are intersecting point B. So at this particular point, we will have a simultaneous equation. These two equations are considered. That means these two equations are intersecting at point B. So we have to solve this simultaneous equation so that we will get the value of x and y at point B, that we will calculate later. Then at point C, see, the value of x is equal to 1200. Value of x is equal to 1200. And what is the value of y? What is the value of y is here? It is the 0. So in order to find the value of x and y at the corner point B, see, all the remaining points we found here, x is equal to 0, y is equal to 0 here, x is equal to 0 and y is equal to 1000 here. And at the point B, we don't know what is the value of x and y. We want to find out. So in order to find out the value of x and y at the corner point B, at this particular point, we have to solve these two constraints or these two simultaneous equations. So I am going to consider these two simultaneous equations. See, first one is 2x plus 4y is equal to 4000. That is treating equation number 1. And similarly, the second equation is 6x plus 4y, which is equal to 7200. Now see, we can solve the system of simultaneous linear equation we have with the two unknown variable x and y. See, we have the coefficient of y is the same. So we can just subtract the equation number 2 from the equation number 1 so that we can eliminate the value of, the variable y. So we are going to use here, we are going to use the elimination method in order to solve this particular equation. So here, if you subtract these two, then 4y minus 4y, which is equal to 0, then 2x minus 4x, which is equal to minus 4x, which is equal to 4000 minus 7200, which is equal to minus 3200. Dividing the both sides of the equation by using minus 4x, then x is equal to 3200 divided by 4, which is equal to 800. So here the value of x is equal to 800. Now after getting the value of x is equal to 800, we are going to substitute x is equal to 800 on the equation number 1 or 2. We are going to substitute here in the equation number 1. So by considering the equation number 1, that is 2x plus 4y, which is equal to 4000. Then substituting x is equal to 800. So it will become 2 into 800 plus 4y, which is equal to 4000. So if you go for solving it, then it is 2 into 800 which is 1600 plus 4y which is equal to 4000. Then 4y which is equal to, subtracting 1600 from the both side of the equation, it will become 4000 minus 1600. So it will become 4y is equal to 2400, and dividing the both side of the equation by using 4, y is equal to 600. So here the value of x is equal to 800 and the value of y is equal to 600 at the point B. So at this particular point we are solved the simultaneous equation, and now the value of x is equal to 800 and value of y is equal to 600. I am going to substitute here. So x is equal to 800, y is equal to 600. Now all the values, that is x and y at different corner points, it's already written here. The next step is we want to find out the optimal solution. We want to find out the optimal solution. So optimal solution will be find out at the point where the maximum profit from the given 4 corner points, that is corner point O, A, B, C. Out of these 4 points, one of the point is the optimal solution where the profit will be maximum. So how we can able to know the profit is maximum? See, this is our objective function, that is maximization of profit, that is 100x plus 80y. We are going to substitute here the value of x and y on the different corner points. So for example, in the corner point 0, that is O, x is equal to 0 and y is equal to 0. I am going to substitute x is equal to 0 and y is equal to 0 on the objective function. Then it will become 100 into 0 plus 80 into 0, it is equal to 0. Similarly, we are going to consider the vertex or corner point A where x is equal to 0 and y is equal to 1000. So here I am going to substitute x is equal to 0 and y is equal to 1000 on the given objective function. Then it will become, z is equal to 100 into 0 because x is equal to 0 here, y is equal to 1000. So it is 80 into 1000 which is equal to 80,000. So it is equal to 80,000. Profit is equal to 80,000 at corner point A. Now the third corner point, that is corner point B, where x is equal to 800, y is equal to 600. If you go for substituting x is equal to 800 and y is equal to 600 on the given objective function, then it will become, z is equal to 100 into 800 plus 80 into 600. If you go for solving it, then it will become 1,28,000. It is 1,28,000. Similarly, the last corner point, that is corner point C, at this particular point, the value of x is equal to 1,200 and the value of y is equal to 0. We are going to substitute these values on the objective function. Then the z is equal to 100 into 1200 plus 80 into y is equal to 0. So it is 80 into 0. So if you go for simplifying it, it is 1,20,000. So it is come out with 1,20,000. So now, see, you just compare the profit at different corner points, that is corner point 0, A, B, C. See, at 0, the profit is equal to 0. Then at A, the profit is equal to 80,000. At B, profit is equal to 1,28,000. At point C, it is 1,20,000. So out of this, the maximum profit which is happened here, it is 1,28,000, which is at the corner point B. So out of these calculated values, the objective function, see, the highest value or profit is 1,28,000, and this is considered as the one of the optimal or the maximum profit, or this is the optimum point. All these are the feasible point, but out of all these feasible point, we have only one optimal solution, that is lies at this particular point where the highest value, where the profit is highest, that is 1,28,000. So we can say that this particular corner point, that is corner point B, where we already know in the graph it was an intersection of the two corner point. At that particular point, the x is equal to 800 and y is equal to 600 and the profit is equal to 1,28,000. So in order to get the maximum profit, see here, the company wants to produce, number of unit of commodity X per month, that is 800, and the 600 units of commodity Y should be produced so as to maximize the company's profit, and the maximum profit is 1,28,000. So this is the solution to the given linear programming problem. So I hope you understood this. See, the graphical method is considered as the one of the easiest way to solve the small linear programming problem, where we are considering only two variables, that is variable X and variable Y. That means we have a two decision variable. Here we have a commodity X and commodity Y. So in this case, we can easily find out the solution to the linear programming problem by using the graphical method. Especially we are discussed here the solution to the linear programming problem graphically when we have a maximization of profit or maximization problem. In the next lecture, we will consider how to find the solution to the linear programming problem graphically when we have a minimization problem as against what we are explained today, that is maximization problem. So in the next lecture, we will discuss the minimization problem. So we'll see in the next lecture. Thank you.